Alright, so for this third section on the functions unit, we're going to be focusing on finding the domain and range from an equation. Okay? Um, this is basically, we already talked about what the domain and what the range is. Domain are the x values, range are the y values. And we know how to identify those when they give you some sets or a graph or something like that. Alright, in this case, we're going to use one to find the other. Okay, like meaning we can't just get them both from the information like we did earlier in the chapter. So now we're going to need to use the domain to get the range, or use the range to get the domain. Okay. So before you do this notes, make sure you do these two warm-up problems from the last section. Get them checked off by me before you go on, just to make sure you're still good with that stuff. Okay. All right. So this first part of the note says, remember with function notation. So remember function notation. All right. The way that that's written is this. Instead of just using the regular x and y, function notation is f of x, which is a function of x. And f of x always equals y. Okay? And in this case, y is the range, like it always has been. Okay? So when making a point from this notation, so when we use f of x equals y, remember, the x is the x that gets plugged in, right? We substitute the x into the f of x, and that gives you out the y. Okay, so it's still, kind of the same thing. We're just saying the same thing in a different way. Okay, but here's the key. All right, now if you remember the first podcast that you watched with the function man. So remember, well, once we figured out the equation of the function, we would plug in x values and it would give us the y's, right? So in addition to calling x, so x now has a few names, right? We know x is the domain. But in the case of the equation, the x is also the input. Okay? And remember, all those equations on the first podcast, we would input -2, -1, 0, 1, and 2, because those are the easiest numbers to put in, right? But technically, we can put in any number that we wanted to for x. And because we can put any number in for x, we also call x the independent variable. All right, this is something we haven't talked about. This is very important now. X is independent because we can plug anything in. We just chose the easiest numbers, but you can do anything you want. All right, now on the flip side, the y, if we were to give it its names, the y obviously is the range. The y is the output. So on that first podcast with the function man, remember we put in the x values, you plugged it in the equation, and out came the y. The y is your final answer. And in this case, because x is independent, y is the dependent variable. So make sure you're writing all this down. Y is dependent because whatever you plug in for x will change what the y is. So your answer for the y depends on whatever you plug in for the x. All right, so now you need to add that to your memory bank. X is independent, y is dependent. Okay? So let's go ahead and put this into practice here. So for this example, okay, it says given a domain, which, just as a reminder, are the x values, we want to find the range, which are the y values. Okay? So, and here's a note. This is always on the SOL exam. They put these types of questions all the time. So here's what we need to do here. They're giving you the domain. They're x's. They're telling you the domain are these numbers. Okay? So, this is a step harder than before. Remember before they would tell you the x's and the y's, and you just had to practice domain and range. Well, now they're only giving us the domain. So what we're going to do to find the range, which are the y values, is we're going to have to take all of these numbers, -2, -1, 0, 1, and 2, and we're going to plug them each in for x. We're going to solve this to get the f of x. Remember, f of x is the same as y. So we're going to use the x's to get the y's. We're going to input the x's, and the y's will be the output. Okay? So for us to do this, so we're going to plug in the first domain value is -2. That's the first number it has, right? So let's go ahead and work this out. All right, so the equation is f of x equals -3x minus 4. Okay? So remember, f of x is the same as y. It means the same thing. So I'm going to plug in my value of x. So this goes all the way back to chapter 1, substituting with parentheses. Negative 3x minus 4, that's the equation. I'm going to plug in negative 2 first. Now you can use your calculator, but make sure you PEMDAS. We must multiply first. Negative 3 times negative 2 is positive 6. Bring down the minus 4. And finally, so the y will equal 2, or the f of x. Okay, however you say it. So when we put in negative 2, out came positive 2. Okay, and we're just going to continue down the line like that. Now we're going to plug in the next domain value, which is negative 1. So we're going to plug it into the same equation. We're still going to plug it into this y equals negative 3x minus 4. Now we're plugging in negative 1. So now we PEMDAS it. And so now y will equal negative 3 times negative 1, positive 3 minus 4. So now y will equal negative 1. Okay, I'm just doing the computation quickly, but you're just going to do the same thing with your calculator. So in went negative 1 for the x, out came negative 1 for the y. Okay? Now we're going to go down the line. Now we're going to plug in 0 next. Okay? So now when I plug in 0, y equals negative 3, parentheses for my x, minus 4, same equation, plug in 0, negative, so now the y equals negative 3 times 0, which is 0 minus 4. Final answer, y equals negative 4. So we're going to fill in this chart. So when you plugged in 0 for the x, the output, or the y, was negative 4. And we're almost done. Now we're going to plug in a positive 1. Okay? And just so we're familiar with both ways, now instead of saying y, I'm going to say f of x. It means the same thing. Right up here, range, y. They put a slash because they're not calling it f of x. It's all the same. It's all good. So now we're doing negative 3, parentheses for my x minus 4. But now I'm inputting positive 1. So now when we solve this, f of x equals negative 3 times 1 is negative 3. Bring down the minus 4. Now f of x equals negative 3 minus 4 is negative 7. So we put in we put in positive 1 for x. Out came negative 7 for your y, or f of x. Last input, I'm going to plug in positive 2. Alright, good enough to erase, make some space here. Okay. Alright, so now I'm going to go to the same original equation. F of x equals negative 3, parentheses for my x, minus 4, and now I'm plugging in positive 2. So now f of x equals negative 3 times 2 is negative 6. Bring down the minus 4. So finally, f of x equals negative 6 minus 4 is negative 10. Alright? So, and now it also asks us to plot the points. Okay? So if I plot these points, let me get a color we can see here. So the first point, remember, domains are the x's, range are the y's, so it's negative 2, 2. So I start at the origin, and I go negative 2 first on the x. X's go first. And let's label this in case we forgot. X-axis, y-axis. So we're going to go negative 2, and then positive 2 on the y. So there's the first point. The second point is negative 1, negative 1. So start at the origin again, go negative 1 on the x-axis, negative 1 on the y-axis. Third point, 0, 4. 0 means I move 0 on the x, so I don't move anywhere left or right. But I do go down to negative 4 on the y. Negative 1, negative 2, negative 3, negative 4. And then I got 1, positive 1, negative 7. So starting from here, positive 1, negative 1, 2, 3, 4, 5, 6, 7. And we're at the end of the graph, so the last point won't fit. Alright, but as you can see here, let me get my straight line tool so we can connect the dots. Ooh, that's not good. So we can connect a straight line through these points to make a linear equation or linear function. It's a straight line. Okay? And just to kind of repeat what we did on the function man one, because it's a straight line, it changes at the same rate. So if I wanted to prove that, look at my domain. It's going up +1 every time. -1 to 0 is +1, 0 to 1 is +1, 1 to 2 is +1. So it's a function when the x and the y change at a constant rate. +2 to -1, that's going down by -3. 2 minus 3 is -1. -1 to -4, it's -3 again. -4 to -7, -3. -7 so because it's changing in a constant fashion, that means it's a function, okay? That's why it's a straight line. Alright, so now it's asking finally for the y's in set builder notation. So after I did all that work, I'm going to put my ranges in set builder. So my range is the set of 2, -1, -4, -7, -10. Alright, so just to kind of recap what we did here, we started with the domains in a set. We took the domains, plugged them in for the x's, out came the y's. Here's our ranges or my y's in a set. Okay? Alright, for this next example, B. Now the domains are, there's only 3, -3, 0, and 4. We're only going to plug in these 3, whatever they give us. Now this will be more challenging because look at the equation. Now the equation has x squared and stuff, so that's why it says use PEMDAS. We have to use our PEMDAS and take care of that parenthesis kind of, the exponent kind of early. Alright, so if I take this original equation, y equals 3 parentheses for my x, and I'm going to plug in 3x squared minus 4 parentheses for my x plus 1. And our first x to plug in is -3. So I'm going to plug it in for both of the x's. Now I'm going to do my PEMDAS. Based on my PEMDAS, I should do my exponent first, right? There's no parentheses to do, so I'm going to go to my exponent. So I'm going to bring this 3 down. And if I punch it in my calculator exactly with the parentheses, it's going to be +9. If you do without the parentheses, it's going to be -9. It's going to throw everything off. Alright? So I'm going to bring everything else down. All I did was the exponent. Now, I'm going to do all my multiplication. So I'm going to multiply 3 times 9, and I'm going to do 9 times -3. Okay, so this will be 27 minus, and 9 times -3 will be -27 plus 1. Okay, and so 27 minus -27, that really means plus. So 27 plus 27 is 54 plus 1. So here my y equals 55. Okay, but now I've got to do it 2 more times. Okay, so now I'm going to do my f of x, and I'm going to plug in 0 for my f of x. Okay, and actually this is another way you can show this. Instead of saying f of x, I can say f of 0 because I'm plugging in 0 where the x is, right? So now it's going to be 3x squared again plus 4x plus 1. And now because I'm putting x or 0 into the function, the x value, now once again we're going to do our exponent first. So now my function of 0 or my f of 0 is going to be 3 times 0 squared is 0 plus, bring everything down. Alright, so I'm still solving for f of 0, function of 0. 3 times 0 is 0, plus 4 times 0 is 0, plus 1. So now, the f of 0, when I plug in 0 for my x, the y value or the range is 1. Okay? Alright, for the sake of time here, and I'm also a little bit out of space, okay, but try to work it out on your own. You might want to pause it here and work it out. But if you plug in, for your f of x, if you plug in f of 4, since that's the last domain to put in, and if you plug that in, alright, what you're going to get here, if you square that, 1648 plus 16, excuse me. That's going to be, so your function when you plug in 4, f of 4 will equal 65. Alright, so these are the three values we got when we plugged in those domain values. Alright, so to put them in set builder notation now, alright, let's go back and look again. We plugged in -3 and got 55, plugged in 0 and got 1, plugged in 4 and got 65. Alright, so we're going to say 55, 1, and 65. Alright, so that's the range. That's the y values we got when we plugged in the domains. Okay? Alright, same deal here, but now they're going to be giving us the range. Now they're going to give us the y values, and we're going to plug in the x's. Alright? Just like what we did, but now instead of plugging in the x and getting the y, we're going to plug in the y's and get the x. Alright? So it's almost identical. You just got to be careful where you plug your numbers in. So here's our range, okay? And always read too, because that's telling you what you're starting with. Here we're starting with the range. Alright, so now when I go into this equation, remember, the f of x is the same thing as y. So now when I plug in these values, I'm going to plug those in here. I'm not plugging it in with the x. Remember, I'm finding the x. That's what we're solving for, okay? So, first one is to plug in 1. So I'm going to plug in 1 for my f of x or my y. Equals, bring the equation down, -2x plus 5. And now we're going to solve this equation for x. So remember, go in the right order. We're going to get rid of the -5 first. Okay, and if I need to draw my line to separate the sides, that's fine. So the 5's cancel out. On this side I have 1 minus 5, which is -4. On this side I have -2x. And then we solve for x, do the opposite. Opposite of times by -2 is dividing by -2 on both sides. Those are gone. So now I'm left with x by itself. -4 divided by -2 is +2. Okay? Now I'm going to do it all over again, but now I'm going to plug in 3 for the y. But I'm still going to solve it for the same equation, -2x plus 5. So I'm going to solve it in the same way. I'm going to get rid of the 5 first by minusing 5 on both sides. 3 minus 5 is -2. Bring down the equals, bring down -2x. And then divide by -2, because we're getting the x by itself. Those are gone. -2 divided by -2 is +1. So in this case, x equaled 1. Okay? Going on to the third one. Now we're going to plug in 5 for my range, or 5 for my y, or my f of x. So now I'm going to plug in 5 on that side, equals -2x plus 5. Alright? Still solving for x. Okay, and if I need to draw my line down the middle again, -5 to get rid of the +5. So on the left side, 5 minus 5 is 0. Bring down the equals. Only thing left here is -2x. Now to get the x by itself, I do the opposite, which is divide by -2. Do that on the other side. X is by itself equals 0 divided by -2 is 0. Okay? Alright, and then the last part here. Okay, a little last space. Alright, I'm going to just do it down here on the bottom. So now it's going to be 7, that's my last y, equals -2x plus 5 again. So we're going to do -5 on both sides. So 7 minus 5 will be 2 on the left side, equals -2x on the right side. Divide both sides by -2. And that will be 2 divided by -2, which is -1, equals x. Okay? So it asks us to put those in set builder notation. So my x values in a set would be 2. Remember, this was this one. It'll be 1. That's the next element in the set. It'll be 0. and it will be -1. Alright, so I plugged in the y's instead, out came the x's, and let's just plot this real quick. So the first point was -2 for the x with 1 for the y. So -2 on the x, +1 for the y. Second point, 1 was the x, 3 was the y. So 1 is the x, 1, 2, 3 is the y. Third point, 0 is the x, 5 is the y. Alright, so 0, 1, 2, 3, 4, 5. And then lastly, we plugged in we plugged in 7 and out came -1. So now it's -1, 1, 2, 3, 4, 5, 6, 7. My bad, I made a mistake. I plotted -2. This was a +2, 1. So this first point was wrong. So now it's +2, 1 for that first point. And as you can see, once again, it makes a straight line. It's a linear function because it changes at the same rate every time. Every time the x went up by 1, or I should say down by 1, so every time it went down by 1, look what the y's did. They added 2. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. So they're changing all at the same rate here.